Hey there, it's Mr. Alexander. Today I'm going to talk to you about sample space diagrams and then how to just answer probability problems that aren't where there is not a diagram given. We have to decide what kind of diagram to use. So I want to start with the sample space diagrams here. A fair-sided die has numbers 1, 2, 3, 4, 5, 6 written on its faces. A fair four-sided die has the numbers 1, 2, 3, 4 written on its faces. The two dice are rolled, and the following diagram shows the possible outcomes. So this is what we call a sample space diagram. Find the probability that the two dice show the same number. So that could be a 1 out of 1, a 2 and a 2, a 3 and a 3, or a 4 and a 4. Now, the 4 is going to be the numerator of the probability. The denominator is going to be how many dots there are, how many possible outcomes there are. And we can figure that out by just doing 4 times 6, which is 24. So 4 out of 24, there's a 1 out of 6 chance of that we have two dice with the same number. If we're going to find the probability that the difference between the two numbers is 1, well, that could be a 2 and a 1, a 1 and a 2. It could be a 3 and a 2. It could be there's the 3 and a 2 right there as well. A 4 and a 3, and a 4 and a 3, and we could also have probability that the two dice show that the difference between the two numbers on the dice is 1. So that could also be a 5 and a 4. So it looks like there's 7 different ways that can happen out of the 24. So that's just a 7 out of 24. So you see what I'm doing here is I'm just counting how many of these marks I've made and then dividing it by how many there are. Let's do part C. Find the probability that the number shown on the 4-sided die is greater than the number shown on the 6-sided die, given that the difference between the two numbers is 1. Well, I see this given that we've subsetted now. We're only looking at these x's, basically. That's our new universe. We're only looking at these 7 numbers where the difference, or the 7 outcomes where the difference is 1. So of these 7 x's, how many have a number on the 4-sided die greater than the 6-sided die? That would be this one, and this one. So it looks like it's 3 out of 7 for part C there. Now that's given a sample space diagram, but what if you're not given a diagram? What if you're just given some information? What should you do? For instance, this one appeared on the IB exam in May of 2016. Two friends, Sensen and Cruz, are conducting an investigation on probability. Sensen has a fair-sided die with 6 faces numbered 1, 2, 2, 4, 4, 4, 4. Cruz has a fair disc with one side red and one side blue. The die and the disc are thrown at the same time. Find the probability that A, the number shown on the die is 1, and the color shown on the disc is blue. It's not clear how we should exactly do this, but I like to think about these problems in terms of a sample space diagram. So I'm just going to draw myself one. So I know that I've got red and blue on the disc, and then on the 6-sided die, 1, 2, 3, 4, 5, 6. Put some dots in here. The numbers on that die are 1, 2, 2, 4, 4, and 4. So what's the probability that the number shown on the die is 1 and the color on the disc is blue? So that's just this one right here. So that's just 1 out of the 12 possible outcomes. What's the probability that the number shown on the die is 1 or the color shown on the disc is blue? So that means, or means one or the other or both. So it could be a 1 or it could be a blue. So that's all these guys too. So I'm counting x's here. I see 7 out of 12. Finally, see, the number shown on the die is even given that the color shown on the disk is red. So we're only looking at these outcomes that are red. And those 6 of those, how many of them are even? Well, that'd be the 2, the 2, the 4, the 4, the 4. That's just 5 out of 6. So that's a nice way to use a sample space diagram to answer a probability problem where there wasn't a diagram given. Let's do another one like that. Rose checks the weather. There's a 20% chance of rain today. Additionally, if it rains today, there is a 40% chance of rain tomorrow. If it doesn't rain today, there's a 70% chance of rain tomorrow. What's the probability that it rains tomorrow? Well, you could use a fancy probability equation to figure this out, or you can realize that this is begging to be a tree diagram, where it either rains today, or it doesn't rain today, and then tomorrow it either rains or it doesn't rain tomorrow. So, to find the probability that it rains tomorrow, there's 2 places that happens, here and here. I need to find those conditional probabilities together, and then I need to add them together. So, 20% chance of rain today, that's 0.2, which means that's got to be 0.8. If it rains today, then there's a 40% chance of rain tomorrow, which is 0.4, which means that's got to be 0.6. If it doesn't rain today, then there's a 70% chance that it rains tomorrow. 7.3. So, to get the probability that it rains today and it rains tomorrow, that's 0.2 times 0.4, which is 0.08. To get the probability that it doesn't rain today, but it does rain tomorrow, is 0.8 times 0.7, which is 0.56. So to find the probability that it rains tomorrow, all you need to do is go 0.8 plus 0.56, which is a 0.64. 64% chance of rain tomorrow. Let's do a couple more. Right here, a survey was carried out on a group of 200 people. They were asked whether or not they smoke. And then we gathered the information at a table. We're going to pick one person at random. We're going to find the probability that that person is a smoker. So if I was to make some totals here, then it looks like there's 100 males and 100 females, 90 smokers, and 110 non-smokers, and of course the grand total is 200. That's what they told me. So the probability that somebody's a smoker is simply 90 out of 200, or if you prefer, 0.45. 45% chance somebody's a smoker. Write down the probability that this person is male, given that they're a smoker. So that given that means we're only looking at the people who are smokers. My new universe is just these 90 people. Of those 90, 60 of them are smokers. So that's just 60 out of 90, which is like 0.667 to 3 significant figures. And then finally find the probability that the person is a smoker or is a male. Or means one or the other or both. So I'm looking at, okay, these people are smokers, and this person's a male but not a smoker, but I need to include all 3 of them. So it looks like that's 130 people out of 200. Or if you prefer, 0.65. Now we could have approached this with a Venn diagram and done all this. I didn't, because I think it's easier to not do the Venn diagram. But if you like Venn diagrams, here's your universe of 200 people. Here are all your males. Here are all your smokers. It looks like there are 60 males who are smokers and 40 males who are not smokers. There are 30 females who are smokers, and there are 70 females who are not smokers. And so you could have gone about all of these questions the same way. Like finding the probability that somebody is a smoker, well, it's just these two. The whole smoker circle is 90 out of 200. Probability that a person is male, given that they're a smoker, so you're only looking at those 90 smokers, 60 of whom are male. Find the probability that a person is a smoker or a male. That's these three numbers again, just added together. So you could have used a Venn diagram for this problem, but I'm not sure that's necessarily the easier thing to do than just looking at the table. Your choice, of course. Alright, this is the last one I want to do. Nene and Decca both play netball. The probability that Nene will score a goal on her first attempt is 0.75. The probability that Decca will score a goal on her first attempt is 0.82. Calculate the probability that Nene and Decca will both score on the first attempt. Neither Nene nor Decca will score a goal on their first attempt. So I'm thinking this is a tree diagram again. And the first branch is Nene scores or Nene doesn't score. And then the second branch, of course, is that her friend scores or doesn't score. And I can fill in these probabilities, so 0.75, which means this is 0.25, this is 0.82, which means this is 0.18. So to find the probability that they both score in the first attempt, that's just right here. It's just that 0.75 times 0.82. 0.75 is 0.82, it's 0.615. And neither Nene nor Decca will score in the first attempt. So that's this one right here. So I'm doing that 0.25 times the 0.18, which is 0.045. So the basic strategy is, if you're given a probability problem and you're not given a diagram, think about what kind of diagram might be useful. It might make the problem easier. It doesn't always. Sometimes it's easier just to do the math, but on occasion, you can build yourself a diagram and you'll have better luck. Thanks for watching. We'll see you next time.